Hi everyone, and welcome to another Logic Apps Aviators Day session. My name is Dan Probert, and I am the CTO of Aptness Limited, a company based in the UK. We specialize in Azure integration services solutions and have been doing so for many, many years. Today's exciting topic is throttling patterns. Specifically, how do we handle thousands of concurrent requests in Logic Apps? So let's get going. I wanted to start off just talking a little bit about what throttling is. I assume that most people will understand this, but throttling is the practice of artificially reducing the number of transactions that we're processing over a given period of time. So we do that because we're trying to stop some sort of a limit being reached or overrun. The reason we will do throttling or implement throttling is to prevent overload. For example, if we have too many requests being processed, we might find that the system's unable to take on any more requests or even process the requests it's got. Or if you're in a situation where you have multiple tenants with lots of consumers, you don't want one consumer sending so many requests that it prevents other consumers from being able to use the service as well. That might be more apparent, say, in a shared cloud service. So let's say I'm using Dynamics 365, and I'm using a Logic app to connect to it. There's going to be some sort of rate limiting on or throttling put on to prevent me consuming all the resources for Dynamics and therefore preventing other people from accessing Dynamics as well. The types of limits that we might introduce or might find could be things like the maximum number of messages that are in memory at any one time, or maybe the number of connections we have over a protocol. So over HTTP, how many requests can we have to a given resource over a given period? There's also limitations on, say, the hardware or the software that we're running on. Logic Apps, for example, is running on virtual machines. So there might be a limit in terms of the amount of memory that's available or CPU power that's available at any given time. So we might want to throttle to make sure that we're not exceeding our limits. I'm going to use sort of trampolines as a metaphor here, but imagine you've got a trampoline and you've got a queue of adults trying to get onto that trampoline. I did start this using children, and I thought that's just going to go weird if children are jumping off the trampoline suddenly. But if the trampoline can hold 5 adults safely, and each adult is allowed 10 minutes on the trampoline, and then they have to get off, we have a limit of 5 adults every 10 minutes, which is another way of saying 30 adults an hour. So that's our limit. We have a limit of 30 adults per hour. Otherwise, we're exceeding the limits of we're exceeding the maximum number of adults that we can have safely on that trampoline. But what happens if adults are slow to get off? If we don't start throttling the way adults are getting on and have someone saying, right, we've got 5 adults on the trampoline, you can't have another one getting on until someone's got off. If we don't do that, then we'll get a 6th adult on the trampoline, 7th, 8th, 9th. And we could end up with 15 adults suddenly on this trampoline, and the trampoline could break. And that's why we have throttling. Throttling is to try and prevent a situation where we break a system. And it's really, really important in the cloud, because the cloud is all about maximum scalability. With the cloud, we don't have to think about the VMs we're running on or the CPUs or anything like that. The idea is it scales up for us. If you've come from a background of Logic Apps consumption, you know that as a Logic App receives more and more requests, more instances of that Logic App will be spun up to handle those requests. So as a developer, you don't have to think about the infrastructure that's going on behind that. It's kind of magic. Microsoft look after it for you. You obviously pay for the number of Logic Apps that are running. But when we start talking about Logic Apps Standard, which is what we'll be focusing on today, there are limits, because now you're running in a VM. It's a single tenant. So all your workflows run on a VM, and the size of that VM is dictated by your app service plan. So once you start hitting those limits, things will slow down. You'll start getting exceptions or retries or something like that. So you need some way of controlling how many messages are getting into your workflows at any given time. There are multiple ways of throttling inside AIS. And I'm not going to cover all of those today. I want to talk about a particular scenario you might come across and a couple of ways to solve that. But one of the first ways is controlling the number of messages that are coming into your workflow. So the size of your batch, for example, and there are lots of ways we can look at doing that. So if I've got 50 messages coming in, then I can choose to use the split on command, in my trigger. And if I do that, I'll get 50 separate workflow instances running to process it. And that might exceed my limit. If each of those is calling a third-party service and it can't have more than 50 concurrent requests, then that's not going to work. What I could do then is take that batch of 50 and use 4 each, and then put concurrency limits on 4 each and say I only want 25 of those processing at a time. So that's the other way you can do it. You can control the number of messages you're processing in that batch. There's another thing to talk about, and some of you may have hit this, which is if you are hitting a system downstream and you're sending too many messages, ideally that system should send you back an HTTP 429 status code, which means too many requests. So it's basically saying you've sent me too many requests and I'd like you to retry them. And when the Logic App's execution engine gets a 429, it implements its retry pattern. So if you've got a retry policy turned on, it will automatically start retrying that request in the hope that subsequent requests will succeed. But it does it the certain number of times that you've got in your retry policy and then gives up. There's another way we can manage throttling, and that's move the messages off your input stream and then batch select them from somewhere else. And that's kind of what we're going to be looking at today. It'll make more sense when we get to the demo. Don't worry, I won't keep talking for too long. This session today is all about demos. So let's look at an example of where we might overload AIS. And I've done this multiple times by accident, and it always happens with Service Bus. But imagine we have a Service Bus topic with 5 messages on it. So we have a workflow using the Service Bus connector, built-in or managed, doesn't matter, but for our case, let's assume built-in. And we want to write each message to a table. Now that could be a storage table, SQL table, doesn't matter. But if we've only got 5 messages in it, and that workflow is set to use split on, what will happen is when we enable the workflow, it will connect to Service Bus and it will select all 5 messages, and it will spin up a separate workflow instance for each of those 5 messages. So what that means is we have 5 concurrent instances running at the same time. That's fine, we're not at risk of overloading anything. But what if we've got 1,000 messages in our Service Bus topic? What the Service Bus connector will actually do is it will spin up 1,000 separate instances of that workflow and try and process them all concurrently. And if your downstream system can't handle 1,000 concurrent instances, you'll start getting errors. And if your downstream system is using 49 errors to request throttling, then you'll start getting retries all over the place. And I want to give an example of this. So let's look at a sample setup I've got in Azure Integration Services and look at what happens. So we've got a Service Bus topic I've created to hold our messages. I've got an Azure storage table, which is representing our downstream system. I've got an API management instance with a policy that we can call from our workflow that will write to the Azure storage table. And then I've got a Logic App with a workflow in it. So what will happen is our workflow will subscribe to the Service Bus topic, and we're using split on, so we'll get a separate workflow instance for every message. And each of those workflow instances will call APIM, and that APIM instance or APIM call will write to the storage table inside the policy. Right, let's go and have a look at this in the browser. So first of all, I'll show what we've got here. We've got an employees topic, and this is as simple as possible. So if I come down here, I've got a single subscription, and I've just got the default filter on there. And you can see there's no messages in our subscription at the moment. Okay. I've set up Azure Storage, a table storage in Azure Storage called employees, with a partition, a row key, and it's got some other properties on it as well that you'll see as soon as we start getting data in there. I've created a API management instance, and I've created a single API in here, the employee API, and it has one operation, upsert employee. And I can take you through what this does, but if I can expand it, I'm in the wrong place actually. Let's come back out again. And from here, right, there we go, that's what I want. This policy here, what that is doing is it is writing directly to the table. So it takes whatever we pass in, it pulls out some values from the JSON data, and it's writing directly to that storage table. And it's got a bit of error handling going on down here as well. And then I have a number of logic apps. I've got one logic app which is going to populate service bus. So I call that and say how many messages I want. And again, that is very simple. It's got some surnames and first names, and it's going to use a for each using debatching and concurrency to write to the service bus topic. And then separately, I've got one using split on. So this will subscribe. It's very, very simple. So all it's going to do is it is going to subscribe to a message in a topic, and it is going to make a call to API management. Now notice I'm not using the brand new API management action just yet. I'm using the HTTP action. I had a problem using the new APIM action. But I'm not using peak lock. This is autocomplete. So it reads the message off the queue. It also has split on turned on as well. And split on means that if there are 15 messages available, I'll get 15 instances of this logic app spun up. I don't have any other control over sizing or anything like that from this. Okay, this logic app is currently disabled. And what we're going to do is we're going to kick off the populate logic app here, and we're going to test it by just doing 5. So this is going to create 5 entries in service bus, and it's done. And now if we come back to service bus and refresh, we should see, there we go, 5 messages. Now, if I come back to my subscribe and send here, and I run it, or enable it, in a second, so these are from earlier today, but if I refresh this, we should get a number of entries pop up. So we'll get 1 entry for each of the messages that have arrived. And we'll start seeing those appearing here. Now, one thing I've noticed with the service bus trigger, it doesn't immediately start running. So what is going on here? There we go. So we have 5 entries that have just run, or 5 entries in the run history. And if we come back over here, we should see, there we go, here are our 5 employees. So the test data, the populate service bus is just generating test data here for us. So it's giving it a random role and then a unique ID for that. And then we've actually got an employee message here with a made up name and everything else like that in it. So cool. All right, so 5, and that went through without any problems. Now, what happens if we do 1,000? Well, let's have a look. Let's send 1,000 through. Now, remember, there's no rate limiting on at the moment. So API management should accept 1,000 concurrent requests. But I'm running my logic app in an app service plane with nothing else in there, but it's a WS1, which means single core. And I think it's 2 or 4 meg of RAM, maybe 3 meg of RAM. It's not a lot anyway. So let's do 1,000. And it's going to start doing that. And what I want to do while this is happening is I'm actually going to disable this so that the messages build up in service bus. But you can see it's already starting to run. And what we'll see, there we go. I didn't disable it fast enough, so it's gone through and it's actually processed almost all of them. And what you'll see here is that the portal locks up. In fact, I can't really get much out of this workflow. If I come back again, I'll come back to run history. And that's because it's doing a lot at the same time. So here we go. It's now executed, hopefully, everything. I've got 40 runs there. I can come down and see more. None of them have taken very long. And if I come back to my storage here and refresh, I should see 382 items. Where are all the rest, you ask? Well, that's a really good question because I don't have 1,000 items. I should have 1,000 items in here. And what's going on is I'm overloading logic apps. I'm overloading the total number of workflows that can run in parallel. And I can see that because I can turn on rate limiting in API management and see what starts happening. But at the moment, here with all these that are running, if we go back to our subscription here, we'll see that there's still only 11 messages left. So the other 889, where have they gone? We could try this again. I've disabled this. Let's run this again and see what happens. So I'm going to send 1,000 messages, and now we should end up with 1,011 sitting in our service bus queue. And in fact, as we come back to here and start refreshing, we should see the count going up. Now, I've got to say, I came across this problem with a client who asked us to stop processing. So disable the logic app that is subscribing to Service Bus. And in the meantime, things are queuing up in Service Bus. And we had thousands of messages in there, 70, 80,000. And when I turned on, when I enabled the workflow, it spun up, well, it tried to spin up about 70 or 80,000. There is actually a limit. I think it's something like 5,000 workflow instances all at the same time, which was not what I wanted, because that then completely bogged down that workflow and that logic app, and it adversely affected the app service plan, and therefore all other logic apps that were running in there as well. All right, so now we've got 1,011 messages there. Let's turn this on and watch what happens. All right, it's on. We currently have let's delete all these. Shall we delete all these? No, let's not delete all of them. Could do. But if I refresh that, let's see what it's doing. It's still only got 382 on here. I'm just going to delete those 382, and we'll see how many we get. We're expecting 1,011 if everything's working. All right, so we've got more coming in. And we've got 41 so far, 84. So it's building up. You can see it's running. And if we come back here, we'll see it is processing, but it's actually running a lot of logic apps all at the same time. It's spun one up for every single message it's found in the topic, which at the moment is 1,011. So all of these are running at the same time. And because we have so many of these running, it means the overall runtime for all of them takes longer. So you can see the times here. We've got them running at 11 seconds, 13 seconds, which they really should be around about the 1 second mark for a stateful logic app. That's because we've got so many running in parallel. Did any fail? Let's go and have a look. And we're looking for ones that failed. And none today. So these are the ones that from testing I was doing. So far, they've all succeeded, which is great. We'll turn that off. Okay, let's come back over here and refresh this again. First 100 items, we've got 1,005 items. Brilliant. So we're 6 down, and it could be that those are still processing and still on their way. And if we come back here to running, we might see, nope, nothing's in a state of running. And how about waiting? Nothing's waiting. Alrighty. Okay, so I've only got 1,005 items, so I'm missing 6 of the items that I would expect to have. That's not too much of an issue for us, because one of the things I neglected to mention is that when I start a run again, I'm overwriting the row key. So 5 of those entries already written in here, so they've become an upsert as opposed to an add. So we've actually got all of our 1,010, 1,011, if you start at 0, items in our table. Brilliant. Okay. Now what I want to do is I want to artificially show what happens when we introduce throttling. So what I'm going to do is I'm going to come back to API management, and I'm going to add a policy element which will start throttling when we hit, say, 100 requests every minute. And we can do that. We're going to all operations here, and I can go to policies. And I've already got it in here. I just happen to have commented out to make it easier for this demo. But this is the, give me a second just to move this over so we can see it properly. This is a policy element that says I would like to restrict or limit the calls to my, well, in this case, all operations. And I'm saying here that what I want to do is I want to rate limit it by key, I want to limit it to 100 calls every 60 seconds, renewal period of seconds. And I'm going to do it by IP address. So my IP address will be limited to 100 calls per second. Because this is being called by a logic app, it's any workflow in that logic app that shares the same IP address. I only want to count ones that are ACP 200. So if I get a 500 or 400 error, don't include those in the counting. Yeah. So that's all I need to do. And if I save that, that has implemented that policy. Now, if I do 1,000 again, what we should see is, I'm just going to remember to disable this. Excellent. And then we will generate 1,000. And we'll come back here, and we are waiting for those messages to start appearing. So there's not many yet. It should be, we go, sending the request to generate another 1,000 messages. And we'll see this start to go up, I hope. In a moment, something's going on. What's happening? Okay, so the workflow failed. Let's try it again. I don't know why it failed. Okay, so we're going to call that workflow and generate 1,000 requests. And hopefully we will see them in here. Here they come. So gradually this will go up to 1,000. And what we're going to do is we're going to turn on the workflow that subscribes and writes out to APIM, but this time we're going to get some throttling. So every time we hit 100 requests, we'll end up in a retry. Now that workflow is just using default options. I haven't changed anything. So this here, the retry on it here is the default. Oh, networking, here it is here. Retry policy is default, which is exponential. I think it's 3, something like exponential intervals. I think it's 3 retries with like a minute between or something like that. I can't remember the exact options for it. But if we enable this now, because we should be up to 1,000, yep, 1,009 messages. So now if we enable this and watch what happens, because what will happen is we'll probably get the first 100 running, and then we'll start getting rate limits. So we'll start getting 429 sent back, which will mean those workflows will go into a retry, and they'll keep retrying. But everything's running all at the same time. So we're kind of going to be consuming a lot of logic app resources while we wait. So the entire run will take quite some time to finish. If I come back to here and refresh here, this was when we had the earlier items in. So let's delete those. Okay, brilliant. All right, it's already sticking some in. So that's the first 100, 104 items. So right now it is running through and trying to process all those. And if we refresh in here, we should start seeing lots running, and we should see a whole lot here in a status of running. And if we come down and look into them, we'll see too many requests. So it's retrying at the moment, and it will keep retrying until it hits that 3 retries and then stop. It'll give up. Now this is something really important. We've done an autocomplete. So we've pulled the message off the topic, and it's now in our care. So if this times out because it can't call it, we've lost the message. Well, we've got it in the run history, but we haven't done anything with it. Just something to remember if you're using Service Bus topics or queues. Be very careful about whether you're using peak lock or autocomplete. Peak lock doesn't necessarily solve the problem either, because peak lock has a maximum timeout of 5 minutes. So if you pull something off Service Bus and your processing takes more than 5 minutes because it's retrying or something, it will be made available back to that queue or topic again, and you run the risk of duplicates, depending on whether this eventually goes through. So right now, what's going on is we have a lot of entries all running at the same time, yeah? And they're going to be running for some time. So what we will see as these start to complete is the amount of time taken to complete each individual workflow gets higher and higher and higher. And some will start timing out. So we're looking at a minute at the moment for some of these. So that's because it's going through and doing a retry. And your hope is that eventually they will succeed. And I think a lot of developers rely upon this default retry without thinking about it and just hope that in a high load situation they will get through. But that's not always the case. If what was calling your workflow is, say, an HTTP action, it has a timeout on it. Maybe it's 2 minutes, and now suddenly the caller has timed out, and maybe it resubmits the message again. It's a lot of complexity in here in terms of how we handle these scenarios. But at the moment, we're waiting a long time, look, 2 minutes now for this one to run before it completed. And if we come back here and see how it's getting on, where are we up to? 306 items. So it's taking quite a while to do all of them. And what I've discovered with my testing is it never gets to 1,000. We never complete it all. We don't end up with all 1,000 items. If you were a bank and each of these messages is a transaction, you'd be rather unhappy if you'd lost some of these messages just because there's load going on. What this means is that throttling is vitally important, and we really have to think about the systems we're calling and how many messages we can process and how we control the number of messages we're processing at any given time. So one of the solutions that I want to show, and this is just an example of how you could solve the problem. I'm aware of time at the moment, but I come back to here. One of the things we can do is change what we're doing. So instead of going from service bus to a workflow directly to APIM, we can go out to SQL. It doesn't have to be SQL, but I've chosen SQL for a very good reason. And then we can go from SQL to workflow out to APIM. So we're offloading things into SQL. Now let's give an example of this working. I need to come back to here, and I need to disable this workflow. And I'm going to create a new workflow. And righty, so I want a new workflow, and this workflow is going to be something that's going to subscribe to messages, and it is going to be, so service bus subscribe, and then it's going to write to DB. Yeah, and stateful's fine for this. Okay, so it's going to write to DB. So first thing I'm going to do is I am going to disable this workflow because I don't want it running straight away. And I already have the code. Paste it in, save that. And all it's going to do is, if we look in the designer, it's going to subscribe to messages, and then it's going to write them out to SQL. I think I hit the designer too soon before it had finished compiling. There we go. So when the message is available, it's going to call a stored procedure. And that stored procedure is just going to insert the data into SQL Server. Brilliant. So I'm going to enable this. And I'm going to kick off my workflow and do another 1,000 messages. And what we should see is things should start appearing in SQL. In the meantime, we only ended up with 511 items here. Now, if we go back and look in here, we'll see 0 messages inside here. So we've consumed all those messages, but we only wrote just over 500. So the other 480 odd have disappeared. Where did they end up going? Good question. All right, so this has failed. I often see this when Logic Apps is busy. So it's really busy working on something. I'll get an error, but I'm just going to try again. And we should start seeing the numbers here going up. Here we go. Now you'll see them going down again because I've enabled this SB subscribe and write. So it's currently going through and receiving them and processing them. There we go. See, it's running. And I can come out to SQL. And if we have a look at what we've done in SQL, we have got an employees database, and we've got a table called employees. And in there, I'm just storing a unique ID and a control status. Yeah. So as I write these out here, you'll see that they have a control status of new. I've got the actual message and a tracking ID. And it's the control status that helps me control what I'm doing with them. So these haven't been processed yet. And I can tell that because it says new. But this is the actual message we want to process. Brilliant. So now we're logging all these out, and we've got 911 rows, and we should end up with 1,000 rows. There we go. So everything has been logged into SQL. Now all I need is a way of getting them out of SQL and back into API management. And I can do that by having another logic app. And this one's going to be database subscribe, call APIM, stateful. And again, I'm going to paste this in. Now, what this is really doing is it's just calling a stored procedure. And that's where the power of what we're doing is. We're writing all our rows from Service Bus into SQL, and then we're calling a stored procedure. And that stored procedure is saying, get me a batch of these messages. And it's saying, get me, I don't know, 50 of these messages. And it sets the control status to processing as it does so. As it selects them, it sets the control status to processing. And we know those are the ones we're doing. So, and then when those have finished, it will go again and say, get me another set of 50 that aren't in a state of processing. One of the advantages we have here over, say, doing it throttling via Service Bus is I can use SQL to control which messages I select. So I could say, only select one clerical record at a time in my SQL procedure. So it will say, if there's any other clerical records that have a control status of processing, it won't select them. So it's quite powerful what you can do here. You can do this with Service Bus as well using sessions, but you hit the same problem that the logic app connector for Service Bus will try and drain the queue, will try and get everything out of it, because that's what it's trying to do. But in our case, we just want to throttle. So I can add in another logic app here, another workflow here. And what I'm going to say with this one is this I'm running just for this demo. It's running on a recurrence trigger. So every 15 seconds it will run, and it will call my batch store procedure, say get me a batch of messages. And then it will select the message. Because what this is doing is it's like a claim check pattern. It's giving me just the ID of the messages to process, and it's looping through those IDs. And this is happening concurrently. And so this is saying, get the message from SQL, and then call APIM, and then update the message in SQL. So if I enable this workflow, what I should see is it will start doing about 50 of them at a time. Now, I've already enabled it because I forgot to disable it when I saved it. So it's running at the moment. So it's looping through. So if we come back to our database here, we should start seeing that some of these messages will be in a state of processing. I'll probably see them down towards the bottom. Here we go. They're completing as they run through. And these ones with processing are currently running. And if I look at the stored procedure that I have, which is here, the DQ stored procedure, I have some defaults in there, and I say basically select 50 at a time. So every 15 seconds or so, whatever the recurrence trigger is, it's going to get another 50. But there's a high watermark. So it's saying that once I'm processing 80, don't get any more. So that's a maximum I'm allowed to be processing at any given time. So it will wait till that drops down below 50 and then get another X number to take it up to this number again. So let's say, for example, I hit 80. It will wait till it gets to 30 before it selects another 50 again. So it's got a low watermark as well, which is this minus this. And this is quite powerful. It's something that is hard to do with Service Bus when you're using logic apps. You can do it if you're writing your own service processes for Service Bus, but not with logic apps. So this is quite a powerful pattern that we can use. If we come back here, and I don't think I remembered to clear this table. So we had 511 originally, and we should see this going up. And I'd like to see 691 in there at the moment. If we come back to SQL, we'll see it's still chunking through and processing. So it is processing them slower. If I come down here, I can see that many are completed. And in fact, very quickly, I can do a count. So I can say, select count star. Oh, excuse me. From employees, where control status equals completed. All right, so it's done 413 at the moment. And if I keep running that, that number will keep going up as it finishes processing each one. Alrighty, so that's it. I'm hoping that gave you a great overview of some of the throttling patterns and problems we've got. This is a solution that we've used with clients, and it's worked really well. It might not work for you, but at least it's another tool in your toolkit. Thank you very much for watching, and I hope you enjoy the rest of the sessions. Thank you.